Our next presenter is Matt Monroe. Matt Monroe is a program specialist with the Drinking Water Quality Team in the Drinking Water Standards section. He has a BS in Bioenvironmental Sciences from Texas A&M University. Matt has worked for TCEQ since 2019 as a natural resource specialist and program specialist. His duties include managing the sample collection contracts for PFAS and chemical compliance. Please welcome Matt Monroe.
All right, thank you. Today I'm going to be talking about the PFAS rule. So to give a little bit of an outline what we'll cover today, I'm going to talk about some contaminant information, so give a little background on what PFAS is. We're going to talk about some sampling data that has already been collected. We're going to talk about the opportunity to reprocess some samples. We're going to talk about the rule itself, and give a little bit of a compliance timeline, and then talk a little bit about treatment options. So to start, what is PFAS? So it stands for per and polyfluoroalkyl substances. PFAS are a category of manufactured chemicals. They've been in widespread use since the 1940s. PFAS generally break down extremely slowly in the environment. To give an example of this, the half-life of a long-chain PFAS such as PFOS in the human body is upwards of 5 years. And it's a emergent contaminant. A little bit more background. So it's a synthetic chemical, and when we say synthetic chemical, it was made man-made, so it was made in a lab. It's not naturally occurring in the environment. So it's a synthetic chemical with chains of carbon atoms surrounded by fluorine. Up on the screen, you can see two examples of the chemical structure of two PFAS. They are PFOA and PFOS. Those are two of the most common ones, and those are ones that are being regulated. But that's just an example of two of them. There's thousands of different PFAS. Again, it's used widely in commercial and consumer products, and an acronym that is used for PFAS is PBT. It's persistent throughout the environment. It's very, like I said, it's very slow to break down. This has led to the grouping commonly referred to as forever chemicals. It's bioaccumulative, so this means that they build up in the body of livestock, wildlife, soils, and waters. So it builds up rather than just passing through or being eliminated by natural processes. And it's toxic, so the existing data also indicates that some PFAS are toxic at relatively low levels. To put this in perspective, for regulations, we're talking about regulating at parts per trillion, while some of the other contaminants you may be familiar with, such as arsenic, fluoride, nitrate, those are regulated at parts per million. So just a little bit more background on it. So some common PFAS sources. So nonstick cookware, firefighting foams is a big one, fast food packaging, stain-resistant products, pesticides, and electronics and manufacturing. This is just a little infographic that I thought was helpful to kind of see the PFAS cycle. On my left over there, you can see that the production manufacturing could have PFAS. It could be in the air, or they could discharge it through wastewater. They can send it to a wastewater plant that eventually discharges, and then examples like firefighting foams may run off into streams or groundwater, and then that cycle repeats. And an example of drinking water could be used, if not treated, back to homes and citizens. So some possible exposures: firefighting and manufacturing. Again, if you work in those areas that might have possible exposure. Drinking water that may be contaminated with PFAS would be a possible exposure. Eating certain foods such as fish that could be contaminated with that PFAS would be possible exposure. And then swallowing contaminated soil or dust with PFAS in it, breathing air containing PFAS, or using products or packaging that are made with PFAS or packaged in PFAS-containing materials. Some health effects of it, reproductive effects, such as decreased fertility or increased high blood pressure in pregnant women, developmental effects, or delays in children, including low birth weight, accelerated puberty, bone variations or behavioral changes. There's an increased risk of some cancers, the reduced ability of the body's immune system to fight infections, including a reduced vaccine response. So to give a little bit of a timeline of kind of how the PFAS rule came to be, how PFAS has been present in regulation. So with UCMR 3, with UCMR 3 that was published in 2012, 6 PFAS compounds were sampled with UCMR 3, and that sampling was between 2013 and 2015. And then in December 2021, UCMR 5 was published, and that contains 29 PFAS compounds that were chosen to be sampled in that. And that sampling happened between 2023 and 2025. And then in March of 2023, the proposed PFAS rule was published in the Federal Register. And then in April of 2024, the final PFAS rule was announced, and then in April 26th of 2024, the final PFAS rule was published in the Federal Register. On May 14th of 2025, the EPA recently announced some changes to the MCLs, and then also a final compliance deadline. So they're looking to make changes to the PFAS rule. So for the MCL, they're just going to retain the MCL for PFOA and PFOS. There used to be 5 individuals MCLs, but now it's just PFOA and PFOS. There also used to be a hazardous index, but they're planning to also take that out, so it's just an MCL for PFOA and PFOS. And they also announced they're planning to extend the final compliance deadline. So that would be the compliance deadline for MCL compliance. Previously, it was going to start in 2029, but they're looking to extend that to 2031. So with this announcement, those are the plan changes they're planning to make. We should see from what we've heard, some proposed language of that in the fall of this year, 2025. So let's go into a little bit about PFAS sampling in Texas that we've done. So with UCMR, the unregulated contaminant monitoring rule, that's sampling done by the EPA, their program. So like I said before, it was PFAS was included in UCMR 3 as well as UCMR 5. And then TCQ has done some sampling through our contaminants of emerging concern contract. So for the UCMR sampling, UCMR 3, that was again from 2013 to 2015. It contained sampling of 6 PFAS chemicals, and the water systems that were chosen for that, the criteria was it was all public water systems with a population greater than 10,000, and then in Texas they chose 142 smaller water systems with a population less than 10,000 that were required to participate in that. For UCMR 5, that started in 2023, and it's continuing to ending in this year, 2025. That one, 29 PFAS chemicals were selected. For the criteria for that, all public water systems with a population greater than 3,300 were selected, and then in Texas they selected 106 smaller water systems with a population less than 3,300 to participate in that. A breakdown of that UCMR5 sampling. This data was pulled from the EPA when they made their most recent data release, which was in April of 2025. So of that, there were 6,355 samples. Of those, 1,800 had a detect of one of the 29 PFAS, and then of that, 231 had a detect of the either PFOA or PFOS, which would be the regulated ones. And then from that, 231 exceeded the MCL, and that's because the minimum reporting level for PFOA and PFOS is 4 parts per trillion, and that's what the MCL is set at. So for some the sampling that TCQ did, a breakdown of that. So in FY 2022, 553 samples were collected. Of that, 228 had a detect of one of the 29 PFAS. Of that, 88 had a detect of PFOA or PFOS, and then 28 exceeded the MCL. For FY 23, 875 samples were collected. 65 had a detect of one of the 29 PFAS, and then 56 had a detect of PFOA or PFOS, and then 22 exceeded the MCL. For FY 24, 879 samples were collected. 18 had a detect of one of the 29 PFAS, and then 11 had a detect of PFOA or PFOS, and then from that, 1 exceeded the MCL. And then for FY 2025, so far, this was from June of 2025, 536 samples have been collected. Of those, 41 had a detect of one of the 29 PFAS, and then 30 had a detect of PFOA or PFOS, and then 13 exceeded the MCL. For this, just get a little background on how we chose this sampling. So these are all systems that weren't part of UCMR5. And for FY 2022, we did a more of a targeted approach. So we looked for areas where we thought PFAS would be present. So for example, like by airports or by industries that would, be creating PFAS. We sampled there, but for FY 23 through FY 25, these have just been systems that would meet the initial monitoring requirements. So for those, we've just been kind of just going through the state and collecting anyone that would meet initial monitoring requirements that weren't part of UCMR5. And then also you'll notice, the exceeding MCL is not exact like the UCMR5 was, and that will make sense when I talk about the next slide. For systems that want to use, so you can use UCMR5 data to meet initial monitoring requirements, but for systems that want to use that, they may have to have their lab reprocess their samples. That's because with UCMR5, the only requirement was report data at or above the UCMR5 minimum reporting level, which again is 4, which is the same as the MCL. But lower levels results could be used to support compliance monitoring frequency determinations. So for example, so for to be eligible for reduced monitoring, the requirement is that the result has to be less than half of the MCL. So it has to be less than 2 parts per trillion. So to meet that requirement, because if you're using UCMR5 data, then that may need to be reprocessed using an NMRL of 2 to be eligible for that reduced monitoring. So for small systems serving 10,000 or fewer, EPA is working with the EPA contracted labs to reprocess that UCMR5 data. So that data will be provided to small systems serving 10,000 or fewer. So the EPA is already working with those labs. But for a large system that serves more than 10,000, the system would need to contact their UCMR5 lab and request that they reprocess that data if they want to use it for initial monitoring. So to reprocess that data with using an MRL of 2 parts per trillion. And this is just kind of a brief what I talked about a while ago. The trigger level is what I was mentioning. That requires it to be half the MCL. So you'll see the MCL for PFOA and PFOS is 4 parts per trillion. That trigger level is right at 2. So it would need to be less to be eligible for reduced monitoring. And we have the TCQ samples that we've collected. We've worked with our lab for them to reprocess that, and we've gotten those results. So that's why in that graph where I was showing TCQ data, the detections and MCL exceedances weren't exact. So if a UCMR lab, if the lab you use cannot meet the method data quality objectives for reprocessed data, the lower level data can be reported as a numeric value and then notated with a qualifier flag, so that and it can be done this way with the qualified data because it's just used to for scheduling purposes. It's not used to meet that MCL compliance. Okay, so to talk about the rule itself. So for the rule, the PFAS rule applies to community and non-transient, non-community water systems. The rule has a maximum contaminant level goal as well as a maximum contaminant level for 2 PFAS, and that's what the EPA is planning. That's what they announced in May, that they're just going to have those 2 PFAS, PFOA and PFOS. And then the PWS requirements would be monitoring and reporting, public notification, and then reducing levels to standards if they're exceeding. So this is just a table showing the MCL. So for PFOA and PFOS, that MCL G goal is 0 parts per trillion. That's not the enforceable level. That's just the goal that the EPA had set. As far as the enforceable level, which is the MCL, that's 4 parts per trillion for both PFOA and PFOS. So for monitoring requirements, so for initial monitoring requirement, so with groundwater systems with population 10,000 or fewer, they're required to collect 2 samples a year at each entry point to the distribution system, and those need to be collected 5 to 7 months apart. For groundwater with a population greater than 10,000, they would be required to collect 4 samples a year, so quarterly at each entry point to the distribution system, and they would need to be collected 2 to 4 months apart. And then for surface water or groundwater under the influence of surface water, no matter the population, they would need to collect 4 samples a year at each entry point to the distribution system, and those would need to be collected 2 to 4 months apart. So quarterly there as well. So for initial monitoring requirements using previous data, as I said, previous data may be used if sampling was conducted according to specific data quality assurance criteria as part of UCMR5 or TCQ sampling, or appropriate monitoring efforts using EPA methods 533 or 537.1. And those samples would need to be collected on or after January 1st of 2019 is the earliest those could be collected. So for systems that are wanting to use UCMR5 data for initial monitoring, some systems may need to collect additional samples. So for example, a large groundwater public water system, as I showed in the previous slide, if they're over 10,000, they need to collect 4 samples or quarterly, but for UCMR5, they were only required to collect 2 samples. So they would need to collect those additional 2 samples to meet initial monitoring requirements. So, for example, if that groundwater system that had a population over 10,000, if they sampled in February and August, so for the February one, they met first quarter, and then for August, they met third quarter requirements. That PWS would need to take an additional sample for second quarter, so in April, May, or June, and then they would need to take another sample for fourth quarter in October, November, or December. And for these, they would also need to be 2 to 4 months apart. But for these, the year doesn't matter. It would just need to meet the monitoring period. So first quarter, second quarter, third quarter, fourth quarter. It just needs to meet that monitoring period. So for recent data, so the most recent initial monitoring data will be used to determine the system's compliance schedule. If a system has multiple years of data, the most recent data will be used. So after you've completed your initial monitoring data, you could be eligible for reduced monitoring. So to meet that, the system would have to be, at each entry point, the samples would have to be, those initial samples would have to be below the roll trigger level, which is, again, 1/2 of the MCL, so 2 parts per trillion for PFOA or PFOS. So to meet that reduced monitoring, so and it is entry point specific, to meet the reduced monitoring, then the PFOA and PFOS would have to be less than 2 parts per trillion. And if it is for any water system, then 1 sample would need to be collected every 3 years. They could move to that schedule, 1 sample every 3 years, if it's less than the roll trigger level at each entry point. So after initial monitoring, if there is an exceedance, it would have to be, the samples would have to go on to a quarterly schedule. So if the initial monitoring samples are greater than or equal to the roll trigger level, which is, again, 2 parts per trillion for PFOA and PFOS, if it's above that, 2 parts per trillion, then they'd have to go on quarterly monitoring. And then when the MCL compliance comes in, that would be based on a running annual average to determine if an MCL violation would be issued. So like our other contaminants, it would be based on a running annual average of those 4 quarters. And if that's greater than the MCL, which is 4 parts per trillion for PFOA and PFOS, then that would be a MCL violation. So for monitoring requirements, so if you did exceed, there is eligibility to go to reduced. So if you're on that quarterly, so after 4 consecutive quarterly samples, so after a year of quarterly sampling, if all those results are below the MCL, then those entry points, it's at each entry point they can go down to annual monitoring, so it's entry point specific there. But if after a year of quarterly sampling, if that site results are less than the MCL, then it can go to annual monitoring. And then once it's on annual monitoring, after 3 consecutive annual samples, if those are each below the roll trigger level, which again is 2 parts per trillion, then it can be reduced to 1 sample every 3 years. There are some public notification requirements. So for the MCL, it would be a tier 2 notification, and that would have to be 30 days of the violation. For a public notice would also be needed on for a tier 3 violation, so that would be a monitoring or reporting violation. That notice would have to be as soon as possible, but within 1 year of the violation. And with the tier 3 M&R violation, you could put that in your CCR. And then speaking of the CCR, for the CCR, if you have detections, you would have to put the level of PFAS in that CCR, along with health effects language. And again, you can include those tier 3 monitoring reporting violations in that CCR. Some important dates for the PFAS rules. So By 2027, the initial monitoring must be completed. And again, you can use previous collected monitoring data for UCMR5 or TCQ sampling. And then starting in 2027, that's when ongoing compliance monitoring would begin. So that's when we would use those things I just talked about to put you on either reduced or quarterly. And then starting then, you would also need to start including your results of their monitoring in the CCR. So if you had detections, you'd have to put that in the CCR. And then the monitoring and reporting public notice, you'd have to start doing those. And then this is the one that the EPA is looking to extend 2 more years. So starting in 2031, systems would must start complying with the MCL contaminant rule. So in 2031, that's when MCL compliance would start. And then with that, if you receive an MCL violation, you would have to do that Tier 2 public notice. And then real quick, just to go through some treatment options. So this chart here is the EPA's proposed best available treatment for PFAS removal. So the first one here is granular activated carbon. It's better at removing long chain PFAS. And examples of long chain PFAS are PFOS and PFOA. So it's better at removing those long chains. It's less energy intensive than RO, and then the media may be replaced. The cons would be it's less effective for short chain PFAS. The pressure vessel or independent treatment unit must be added, and then media disposal may be an issue. For the next one, anion exchange, it's better at short chain PFAS, are more likely to be removed. The cons would be a disposal of that resin. And then lastly, nanofiltration or reverse osmosis. It's effective in removing both long chain and short chain PFAS, but it's energy intensive and costly, and the disposal of waste may add to the cost. For treatment questions, the best group to reach out to would be our technical review and oversight team. They're the ones that have been really looking at the treatment options, so they would be the best ones to reach out for if you have questions about treatment. That's their contact information there. A great program that we have at TCQ is FMT. So if you're starting wanting to look at, PFAS training maybe, they're starting to put that together. They don't have it together yet, I don't believe, but you could reach out to them and get it put on a list to be contacted when that training would be available and assistance. And then lastly, this is my contact information. That first 3 lines is my direct contacts, and then the second 3 lines is our group email, our PWS PFAS email. That's a great email to reach out to, just in case if I may be out or something like that, then someone would be able to see your email there. And then also that's our group phone number there, where you can reach out to us for PFAS questions. But as always, you can always reach out to me directly.